Hi there, my name's Ryan. I'm going to show you a quick demo of some code I slapped together on the bus ride home today. Um, the background of it is um, some data I was playing with a few years ago um, that leveraged IBM Watson Personality Insights API, and I pulled 93 speeches from the public domain, which is about a 250,000 words, and ran it through and analyzed it here. And I'll put these links in the to the GitHub repo with the raw data here, which looks like this. But there's basically 93 speeches from people that include Ronald Reagan, John F. Kennedy, FDR, Martin Luther King, um, and some folks have more than one speech attributed to them. For each one of these speakers, there's a speech that was processed through Personality Insights and gave 52 signals out of it. And to learn more about the service, you can go here to Personality Insights. But that's the raw data I'm going to be working with. So what I did today is I went into R and I wanted to get to know a few 3D programs for clustering this kind of information. So that's the data I'm going to be using. I'm just going to quickly walk you through what I've written here, and hopefully you find it a little interesting. So I started by installing Plot3D in R and just copying in some of the base programs that were here. I didn't actually end up using a ton of this. What this took me to, though, was Plotly. So I installed Plotly. You also need to go and get credentials there. It takes about 2 minutes to get some free creds to use the Plotly API endpoints. And once you do that, you can go in and take the empty cars dataset, which is default install on the R programming language. And let's go and find our chart here. And this is all pretty well documented on the Plotly. See, we're on the Plotly site here, and we've got our cars automatic versus manual transmissions. And again, this took about 5 minutes to get up and running. You can see it's differentiating between our attributes of cars and whether they're automatic or manual, and sort of where they fit into the weight to power to time ratio. So let's go back to our code. So now we're going to pull in our data. So I read in this CSV data here. I added a column to the base stuff called generation shifter, and I somewhat arbitrarily picked a few speakers in here: JFK, Ronald Reagan, Martin Luther King Jr., and I think one more, maybe FDR. And I assigned them as sort of generation shifters, somewhat arbitrarily, as folks that move the needle more than perhaps some of the other that are on here. And here's the data in here. And I wanted to see if I could effectively just jam this data into the Plotly plots. And the short answer is yeah. You'll see it pop up here in a second. That won't look too interesting, fair warning, but here we are. I only took, if we jump back here, 3 of the traits out of the 52 available: excitement, ideal, and self-transcendence, which are defined back on the website there. But it just gives you an idea that it was fairly easy to go and pull those 3 traits that we cared about from there and start to visualize them and chew on them. Not a ton of information in here for us on the visual. So what I did next was loaded up the Kohonen package in R, which is a great package for a self-organizing map. And I'd worked with this a long time ago in doing analyzing hockey player scores and attributes. And again, I'll put some of these links down in the comments field. But I was curious what it might look like using this data. So I pulled in, I don't know, 8 or 10 of these traits out of the data, and I ran the Kohonen self-organizing map on it. And we can see it plotting here. Oops, let's try one more time here. And so yeah, here's the traits, and you can see there's sort of clusters of the attributes Now what this does, this tells us the amplitude of the speakers that are within the buckets, but what it doesn't tell us, and let's dial this down, let's do a 4 by 4. What this doesn't tell us is how many are in here, so we can turn on some of the other plot features within this and tell us how many folks are in there, and if we want to map back and find out who's in what bucket. You can see bottom right, there's a histogram of how many speakers are in each one. So that's within R. Next stop, we loaded Diffusionmap, which is another great program for reducing the dimensions in the 52 or so traits that we've got in our data set here, so we can do a little bit of clustering. So ran Diffusionmap on these guys here, and started to play with the data a little bit. Haven't done a lot in it, but you can see there is some clustering of the generation shifters versus the not. A little bit of random forest for good measure in here. Anyways, this was just the leveraging some old code. What I really wanted to get was to this, because what I wanted to do is take these clusters and move them into the Plotly graph that we had played with earlier on. So I did that, and here's what it looked like in the end. So again, just sort of a high level, curious if I could do it and what the data might look like here. So it starts to get a little more interesting here. Again, it's a little bit faked, if you will, on the clustering and how I've done it here, but it gives you a good idea of how you can take some, high dimensional data and start to work with it and to better understand it. So yeah, Plotly is pretty cool. So yeah, thanks for watching. Hopefully you found some of this useful, and I will post this on my GitHub repo. Thanks for your time.